Welcome to Astronomy Daily, everyone. I'm Anna.
And I'm Avery. We're thrilled to have you join us for another dive into the cosmos, bringing you the latest and most fascinating news from across the universe.
Today on the show, we're going to demystify a plane-sized asteroid making headlines with its upcoming close approach to Earth. NASA says it's pretty routine, but we'll get into why it's still worth talking about.
Then we'll turn our attention closer to home and reignite an age-old debate. Is it truly worth going back to the moon? We'll explore the compelling arguments for human lunar missions versus robotic exploration.
And finally, prepare to be amazed as we introduce you to a newly discovered exoplanet that's pushing the boundaries of what we thought possible with an incredibly short year and some truly extreme conditions.
It's going to be an exciting episode, so let's jump right in.
All right. First up, let's talk about that asteroid that's been buzzing through headlines, 2025 OW. It's being described as plane-sized, and while that might sound a bit alarming to some, NASA experts are really keen on emphasizing that this encounter is far more routine than it is remarkable.
That's right, Anna. This asteroid named 2025 OW measures about 210 feet in length. It's scheduled to pass Earth on July 28th at a distance of roughly 393,000 miles. To put that in perspective, that's about 1.6 times the average distance to the moon.
And despite it zipping by at an impressive 46,908 miles per hour, NASA scientists are saying there's absolutely nothing to lose sleep over. Ian J. O'Neill, a media relations specialist at NASA's Jet Propulsion Laboratory, or JPL, put it quite simply, stating, "This is very routine. If there was a threat, you would hear from us. We would always put out alerts on our planetary defense blog."
David Farnokia, an asteroid expert at NASA's Center for Near-Earth Object Studies, CNEOS, echoed that sentiment, explaining that space rocks passing by Earth are just business as usual in our solar system. He even mentioned that his team typically tracks several asteroids passing Earth each week, with 5 on their radar for next week alone.
So while 2025 OW is certainly large enough to be of interest to scientists, its orbit is incredibly well understood, meaning it poses no danger whatsoever. O'Neill confidently stated, "We know exactly where it's going to be. We'll probably know where it's going to be for the next 100 years. So no need to dust off your asteroid bunker plans for this one."
For those hoping to catch a glimpse, Farnokia noted that 2025 OW won't be visible with binoculars. However, he did point to a much more exciting event on the horizon, the 2029 approach of asteroid Apophis. This one is estimated to be about 1,115 feet in length and will come within an astonishing 38,000 kilometers of Earth in April 2029, which is actually closer than our geostationary satellites.
And the best part? Due to that exceptionally close approach, Apophis will actually be visible to the naked eye. That's going to be a rare and incredible opportunity for public observation of an asteroid. Both Farnokia and O'Neill also emphasized that while Earth is struck by roughly 100 tons of space material daily, most of it is harmless dust.
Larger, more potentially hazardous impacts are extremely rare. Farnokia calculated that for an object the size of 2025 OW, while close approaches might happen yearly, an actual Earth impact would only occur roughly every 10,000 years. It's good to know NASA's planetary defense programs are keeping a close watch, maintaining public transparency, and reminding us that most asteroid headlines are more sensational than genuinely concerning.
So from objects passing by Earth, let's pivot to something that's always been a hot topic in space exploration: whether it's truly worth sending humans back to the moon. It's true that crewed missions are notoriously expensive, difficult, and dangerous.
Absolutely, Anna. And we've got decades of reliable, dependable robotic exploration under our belts. Flybys, orbiters, landers, rovers. So the natural question arises, why don't we just take all the money human spaceflight would cost to return to the moon and spend it on a ton of robots instead?
That's a great point, and one often debated. But the answer surprisingly leans heavily towards the human element. No matter how capable our little robotic explorers are, they simply can't match what a human can do.
Exactly. Compared to a robot, a human is stronger, at least stronger than the kinds of robots we can send to the moon. We can troubleshoot and solve problems much faster without constant guidance from Earth-based engineers. We're also far more creative and flexible when it comes to scientific investigation. I mean, a typical rover speed is around zero point 0.1 miles per hour, or a blazing 152 meters per hour. Humans are just better in almost every aspect for hands-on work.
It's truly astonishing. The typical benchmark is that what a robot can accomplish in an entire day, a human can often do in a minute. Of course, the downsides are significant. Sending humans is much more expensive and much riskier. No one sheds a tear when a robot crash lands on the surface, but a crewed mission is going to be at least 10 times more expensive than an equivalent robotic mission.
And yet, while human missions are more expensive, their productivity totally eclipses that of robots. Look at the Apollo missions. A total of 12.5 contact days on the moon resulted in nearly 3,000 scientific papers. Compare that to the 1,000 or so papers written about Mars from years of rovers and landers on its surface. On a cost per science result basis, it seems we'd be foolish not to keep sending humans into space.
And science isn't the only compelling reason. The moon also holds a lot of easily accessible resources that could provide the basis for space-based industry. We're talking about mining and manufacturing on the moon, utilizing rich deposits of methane, ammonia, and atomic oxygen in the lunar regolith.
This is where it gets really exciting for future expansion. These operations could funnel back either manufactured or refined materials to Earth, or become the backbone of further off-world industry as a steady supply of water and fuel. The moon has a much shallower gravitational well than Earth, meaning it's significantly easier to come and go from its surface. You could literally build advanced rocket parts or habitats there and get them out to Mars or the asteroid belt far, far easier than doing the same thing from Earth.
While we can fantasize about fully automated factories or mining operations on the lunar surface, the truth is we don't have nearly the experience or expertise to develop those kinds of systems outside of Earth yet. Lunar manufacturing and mining are still a long way off. We have to figure out how mining and machining can operate in low gravity, how to deal with all that super fine lunar dust, how to haul all that mining gear there, and where the good stuff is on the moon in the first place.
And to kickstart that entire process, we're going to need a lot of humans doing a lot of grunt work. And lastly, and perhaps most fundamentally, it's just plain fun. Humans are natural explorers. We've always expanded into every habitable biome of Earth, making our way across ice bridges and over the horizons of endless seas to find new homes. It's truly in our nature to explore and expand.
The moon is right there, waiting for us. For millennia, we thought it was just a mysterious part of the heavens. Now we understand that it's a world in its own right, a place to plant our flags and build our homes, a place where a branch of humanity could potentially create new communities.
And there will always be a segment of the population that simply wants to go to the moon for the adventure of it and the desire for a new life. It's not crazy to imagine humanity building cities and homesteads on the lunar surface. It may take a very long time, but it's not impossible. If those people are private individuals spending their own money, then good for them. If it's publicly funded institutions like NASA footing the bill, let's keep in mind that the entire space program of the United States takes up less than 1% of the total federal budget. We're barely spending any money on it at all, relatively speaking.
From our own moon to asteroids zooming past Earth, let's cast our gaze even further out to a truly fascinating new world that's challenging our understanding of planetary systems. Astronomers have just discovered an exoplanet named TOI 2431b.
This discovery was made by an international team of researchers using NASA's Transiting Exoplanet Survey Satellite, or TESS. TOI 2431b is an Earth-sized planet orbiting a nearby star just 117 light-years away. But what makes this planet extraordinary isn't just its size, it's how incredibly fast it races around its star.
You're not kidding, Avery. TOI 2431b completes a full orbit around its host star in just 5.4 hours. That makes it one of the shortest years ever recorded for any known planet. To put that into perspective, while Earth takes 365 days to orbit the sun, this distant world experiences more than 1,600 years in the same time frame. It's sitting extremely close to its star, only about 933,000 kilometers away.
And that proximity comes with extreme consequences. The planet's surface temperature reaches approximately 2,000 Kelvin, which is about 1,727 degrees Celsius. That's hot enough to melt most rocks and metals. Scientists believe the planet's surface is likely molten, creating a landscape of liquid rock and metal. Imagine that.
Despite being classified as Earth-sized, TOI 2431b is quite different from our home planet. With a radius about 1.53 times larger than Earth and a mass 6.2 times greater, this world is significantly denser than Earth. Its density of 9.4 grams per cubic centimeter suggests it's made of much heavier materials, possibly containing a large iron core or other dense metals.
And the intense gravitational forces from its nearby star have likely changed the planet's shape. The team estimates that TOI 2431b is tidally deformed, with its shortest axis being about 9% shorter than its longest axis. This gives it a somewhat flattened appearance rather than a perfect sphere, like Earth, but even more extreme.
Perhaps most intriguingly, this planet won't be around forever. The researchers calculated that TOI 2431b has a tidal decay timescale of about 30 million years. This is the shortest known among similar ultra-short period planets. It means the planet is gradually spiraling into its star and will eventually be consumed, though its demise won't happen for many millions of years.
The Discovery team, led by Kayahan Tosh, confirmed the planet using multiple observation methods, including test data, ground-based telescopes, and specialized spectrographs. Scientists have noted that TOI 2431b would be an excellent target for the James Webb Telescope to study further, potentially revealing details about its surface composition and whether it retains any atmosphere despite the extreme conditions. It really adds to our growing catalog of extreme worlds.
What an episode, Avery! From routine asteroid flybys and the excitement of Apophis in 2029 to the compelling arguments for human missions back to the moon, in the truly wild discovery of TOI 2431b with its 5.4-hour year and molten surface, it's been a journey through some incredible celestial events and discoveries.
It really has, Anna. Our universe continues to amaze us every day. And that wraps up another episode of Astronomy Daily. And a quick reminder to visit our website where you'll find all the latest space news and all things Astronomy Daily. Just visit astronomydaily.io.
Thank you so much for tuning in and joining us for today's dive into the latest space and astronomy news. We hope you enjoyed it as much as we did.
If you want to keep up with all things cosmic, be sure to subscribe to Astronomy Daily wherever you get your podcasts, and follow us on social media for more updates and behind-the-scenes content.
Until next time, keep looking up.